Okay, so welcome to the next practice class. I hope you are doing well. Today we have a fully remote class. The reason is I'm unfortunately feeling a little bit unwell this week. And well, due to that reason, in order to keep everyone safe, I've decided to isolate for this week. I hope it's nothing serious, but it's also something, by the way, that we expect from you. If you don't feel well, stay at home, work with us remotely. And we will try to do the same, not to endanger other people. So please remember that. So today we have our second practice class, and now that we know in what environment are we going to work, so today we will start a discussion of some common mechanisms of how high-level applications that we usually develop interact with the operating system and with other programs. And today we will study the most fundamental interface. It's the status code, the exit code, that you probably saw in many C programs here and there. It's actually one way of how programs can interact with the operating system and other programs. And even though it looks very simplistic, it could be quite useful. And today we will try to see in what way. So as usual, let's jump to our server environment. Okay, so let's jump to our server environment. I will try to move Zoom maybe somewhere to the bottom. Here we go. And we will try to connect with the command ssh auc. Okay, so now that we are on our remote server, so let's go to the directory that we have created the last time for our course, right? It's COM-341. So with the command cd, let's switch to that directory. Last time we have discussed some basic commands like cd, ls to move around of the file system of our operating system here, Unix based operating system. And well, today, hopefully, these commands will not be new. Right, so now that we are in this directory with ls, we can check, do we have anything here? No, we don't have anything here, right? So, we need to create something. And what are we going to create? Well, for that, let's take a look at our course repository into this directory labs and labs.md. And in our labs, we will try to recreate some common Unix commands. So some of the commands that we have already used, like ls, mkdir, eventually. So, but some maybe you hear for the first time, hear about for the first time. So now we will try to do it in order, first of all, to study some common Unix commands and also to discuss how basically we can request various services from the operating system and what services are actually provided by the operating systems and what can we do directly in our programs. So by building these fundamental utilities from the Unix operating system, hopefully we will better understand, what is the responsibility of the operating system and what is possible to do, directly in our programs. So we will start with these two simple programs, true and false, true and false. Let's discuss what is the purpose of those programs. Well, how can we find that out? Well, first of all, before trying to find out what is the purpose of these programs, let's actually ensure that these programs are actually programs. There are executables somewhere on the disk. And please help me. How can I discover that? How can I find out? Do we actually have executables true and false somewhere here installed on this computer? And if yes, what should I need to do in order to verify that? Well, recall the previous practice class. You can write it in chat. Or you can use your mic. Could we check bin directory? Yes, definitely we can do that. So let's go to the bin directory. By the way, not in the home directory, but here in the root of the file system. Right, and we can type ls and we can just search here for programs true and false. And if we do see executables like that, it means, yeah, definitely we have them here somewhere. So let's search for the program called true. Let's find for T, and where is it? Here we go, true. Managed to find it. Indeed, there is some executable with machine code here called true, and it's there in the bin directory. So now that we know that it's indeed a program that we can run, And let's actually run it first without opening any documentation here. What will it do? Let's type the name of that program true. From any location, by the way, not only from bin you can type that. Well, apparently, well, it will do nothing. It will do nothing. Now that's interesting. Right, so now, well, it's a little bit perplexing. What's the purpose of that program? Well, if we can't see that directly here on the screen by running this command, this program, let's actually open documentation for this program. And how can we open documentation for our programs? Well, you see, on most Unix systems, you can also find a program called man. Man stands for manual. Basically, it's a program that can search for manuals, documentation, reference files for various programs, and also, by the way, for library functions in the C programming language too. So usually on most Unix systems, a lot of documentation is installed together with the system itself, and this program man allows us to search for a particular documentation file. So the basic syntax is to write man and the name of the program or file or the name of the function that you are interested in. So, and if the program will be able to find the document with precise name, well, it will try to open that document and display it to the screen with another program called less. Now, less is a program which we call a pager. What is the purpose of such program? Well, you see there are a number of programs that can display text, but usually they just print it out to the screen, and if it's a lot of text, well, it's sometimes that it's a little bit messy in the terminal. You have to scroll, and by the way, not all the terminals many years ago was supporting scrolling, you see? So in order to get an ability to display a large file, to be able to display it page by page, so we had programs called pagers. So one popular pager program was called more. So another one, which is a bit more powerful, is called less. And you can probably see the joke of its name, right? So less is more, right? So, well, basically man will search for documentation. If the document with a particular page is found, it will send it to the program less. And in less, we can display it page by page. We can scroll through the document. So it doesn't matter what kind of terminal do we have. And also we can search for some text inside of that program, which is also very convenient. You need to type slash and whatever you are searching for. And then with keys N and uppercase N on your keyboard, you can go through your search result back and forth. By the way, in order to exit from this program, you need to just press Q. Okay, so now that we know about these two programs, let's try to use them. So I would like to know what is the purpose of this man program. And I would like to do it without Googling. So just directly here in the operating system that I have. I will type man true. So press enter and hope that man will be able to find an appropriate documentation page. Well, it was able to find it, and man sends this documentation to another program called less. And now I see the output of less here directly on my screen. So, well, let's take a look. Now, what do we have here? Well, we have true. The purpose of this program, well, is to do nothing apparently. And not just do nothing, but do nothing successfully. Well, it's a little bit weird, right? So documentation doesn't help us too much, at least here. Well, let's look for a little bit more here text to explain what is going on. Well, you see, apparently this program exits with a special status code, with a special exit code, which indicates success. Okay. So, well, if you had some experience on the computer architecture course, you probably remember when we were writing C programs, usually at the end of our entry point main, of our function main, right, we were, well, sometimes returning some numbers, right? And these numbers is actually a particular inter-process communication mechanism. You see, these numbers have a particular reason on the system. They return to your operating system, and the operating system can pass these numbers to the parent program, the program that was starting another child process. You see? And, well, this number can indicate to the parent process and also the operating system whether our program was successful or not. basically whatever was its main purpose. Was this program able to succeed while fulfilling that purpose? Was it able to do its job? So the program can indicate it by sending the special status code to the operating system and to the parent program that was starting this child process. You see? So, and it's usually just a number. And if this number is equal to 0, it means the program was successful. Whatever it was designed for, it was able to do that. So if it's any other number than 0, it means the program was not successful. It failed to do its job. Maybe there was some error, right? Maybe there was some problem on the system. Maybe the file was not available, something else. Basically, what was the program designed for, it failed to do that. So it can indicate it to other programs, to the operating system too, by sending the special exit code or status code. See, like that. It's a very fundamental inter-process communication mechanism on many operating systems. Not only Unix-like, but even on Windows, a very similar mechanism exists, is present there. Okay, so but here is still a question. Well, this program apparently will do nothing and return 0, right? A successful exit code. But how can it be used? Well, this is still something that we have to answer, right? So, well, but you know what? Before answering it, let's actually try to recreate this program. I think it will be very easy to do on our own. Right, there is a program like that installed on the computer, but let's try to recreate it. How are we going to do that? Well, first of all, I will probably go back to my home directory, and probably the easiest way to do it is to type cd. This will bring me to my home directory. Now I can go to the course directory COM-341, and here I would like to create an empty file, probably that eventually I will fill with the code. So how can I do that? Well, I can open the editor right away here and just provide the file name to which eventually I will write my code. Or I can, well, create an empty file with another command line program called touch. Touch can do multiple things, different things, but one of the jobs of touch is to create new files if the file doesn't exist. If the file exists, it will just update its modification date. So, but if there is no file with a specified name, so the program called touch will create an empty file with that name. So let's try to use it. So I will write touch, and what should be the name of my program? Well, I will first of all write it in the C programming language. So it's probably will be true.c. So I will type that name. By the way, you can type multiple names, and touch will create all those files or update modification dates if the file is present. So then after pressing enter with ls, I can probably verify that. Yeah, indeed. So before it was an empty directory, but now of course we have this true.c file in this folder. So how can I check that it's actually empty? Well, there are a number of possibilities, right? So one option is of course to open it once again in some text editor. So, but well, if it's not a large file, you can also verify it just directly in the terminal by using another program called cat. So cat can display the text content of a file. So, and by the way, if you provide multiple file names, it can present both those files one after another. And you see in the future, we will learn about redirection. So if you will ask cat not to print stuff to the screen, to the terminal, but to send it to some other third file. So it will just combine these two things together, and well, you will get a concatenated result in some new output file specified on the command line. You see, that's the name. It's not because, well, it's somehow related to cat, the animal. Well, it's short for concatenate. The purpose of this program is to concatenate files. You see? So, and you know what? If you will provide just one file name, well, it can also be used to show the content of that file. By the way, if it's not a lot of content, well, cat could be quite useful. But if it's a lot of content, well, less probably is more useful. So less will be able to present things page by page. You can even search there. You can clear your terminal by exiting from it. it's much more useful in that particular case. But if it's a small file or maybe an empty file, so well, cat could be a nice program to check the file's content. So let's try this program too. So let's write cat, let's write true, see the name of the file. And by the way, do you need actually to type the whole name of the file? So actually you see here in bash, we have basically automatic completion of file names. So if you do have here on the disk a file which starts with T and R, or maybe just T here, alright, so it will be enough to type here Z and then pressing here, by pressing here the tab key on your keyboard, you can auto-complete the name. It's also another very useful feature that we get from our common interpreter bash. So you don't actually have to type names fully nowadays, you see? So if you do know there is a directory named something like that, you can type its first letters. And if the name is unambiguous, well, your command interpreter will autocomplete here your command prompt. Okay, so now let's press enter. As you can see, nothing is printed. We just get the command prompt right away. Well, it means yes, that file is empty. This file is empty. So now, of course, it's empty. Let's try to edit it. Well, how can we edit it? Well, there are a number of possibilities. So one possibility is, of course, to use some command line editor. You see programs that allow you to use this text interface to edit files. So it's not always that convenient because a lot of things that you expect here will not probably work. Right, so easy to be able to easily select all the text, to copy it and paste it. Well, it's not available here in the terminal. You can copy, of course, small parts of the text that are visible on the screen, but not basically scroll through the document usually, you see. So there will be a number of limitations. But still, well, it's possible to remotely edit files just directly here in the terminal. There are a number of programs for that. So let's list some of those programs. So one program is called Nano. Usually you can find it on most GNU Linux distributions. So it's very simple to use. It's very user-friendly. It tells you basically what key combinations you can use in order to do basic operations on the file. It tries to create a text pseudo UI, pseudo graphical UI. So it tries to make an illusion that we have a window, you can type there, and so on and so forth. So, but unfortunately, it's not as powerful as some other editors. If it's for the first time you are trying to edit the text here in this environment, so I recommend you to start with that editor. You see, by providing the file name that you would like to edit. So this program will start, it will clear the terminal, it will try to create an illusion that we have a window here by typing all kinds of characters on the terminal, you see, of different color. And also at the bottom you will see what kind of things can you do. You see exit, save, read some file, open some file, and so on and so forth. Now, quite user-friendly, but unfortunately not as powerful as some other editors. So, by the way, if you want to exit here, you need to press Ctrl X as it's written here at the bottom of the screen. Let's actually try that. Here we go. There are some other editors installed here on our server. So another editor, which is, I think, beloved by Dmitry Shostak, is called Micro. He was using it on the safety management course, as far as I remember. So it's another editor. Usually it's not installed by default on most Unix operating systems. You have to install it manually, separately. So it's not bundled together with the distribution itself. So, but well, it's kind of like in the middle from the point of user friendliness and well, the amount of functionality that we get here from it. So once again, usually you will not be able to easily copy and paste stuff here in the terminal. So, but well, it's considerably nice and user friendly. So here, by the way, as far as I remember, it's Ctrl Q to exit. Well, usually the first thing you would like to know in the console editor is how to exit from it. And in different editors, it's a different command. Okay, another two popular editors, which are also usually bundled with the operating system itself. So it's Vim and also Emacs. So there are usually holy wars between users of these two text editors. So like some people like Firefox more, or for example Chrome more, and sometimes, well, on internet forums fight with one another, right? With, of course, words. So here also people usually have all these kinds of holy wars. Which editor is the best, Emacs or Vim? So Vim usually is pre-installed on most Unix operating systems nowadays, or it's very easy usually to get it in some way or form. Emacs is less common, but it's possible to find some distributions with it pre-installed. These two editors are incredibly powerful, but require additional time to study them and to learn how to actually use them. So even basic operations like editing text are not very trivial in these editors. So, but a lot of people believe if you will spend some time with them, if you will get some time to practice with them, at some point it will be very hard to switch to anything else. So these are two very popular editors. So I myself is a big fan of Vim, and mostly on this course I will be using this editor. So, but I am not forcing you to do the same. You can use any other editors like Nano, Micro, Emacs, so you can request some other editor to be installed on this server if you have some personal preference. Also, please remember, you can use Visual Studio Code with the remote plugin, right? So I think during the first practice classes, we have demonstrated, right? You can do that too. So you can install the extension to work remotely, remote SSH, and you can work from this wonderful GUI environment directly on our server if you have everything properly configured on your machine. It's also completely alright, but I recommend you to try to force yourself to work as much from the command line. Why is it so? Well, because eventually when you will go to some real jobs, eventually when you will have to manage some backend services of the system that you are building, so most likely you will interact with servers through the command line. So and it usually will be the only thing available out there. So without any GUI. So it's a good kind of like practice here to limit yourself artificially to be more proficient in such environment. Anyway, so now that we have discussed that, I will go with Vim. By the way, if someone would like to start using Vim after this class, I recommend you to first start Vim Tutor. Vim Tutor is a popular program here installed together with Vim, which will teach you usually in 30 minutes how to do some basic operations here. For example, how to exit, how to move the cursor, and do many other things. So you will spend probably no more than 30 minutes. At least, it will not be too scary how to start this editor and how to do some basic operations. So, but if it's the first time, I recommend you to go with Nano instead. Anyway, so I will type vim true, open this editor, and now it's time to write some basic C code. So usually, of course, if you remember from the computer architecture or safety management, right, so the basic program usually consists of what? An entry point here in C, and it usually looks something like the following, right? So main, we are not interested in those arguments, we can skip them. Right? So we can just write main without argc and I don't care here about any arguments. So, and we can also, of course, here write the return because we have promised to return something. And that thing is actually our exit code, our status code, right? That's something actually, that is used here as some primitive inter-process communication mechanism to report from one program to the operating system and through the operating system to some other program, to our parent program that has started us, the child process, whether we were successful or not. Right? And then 0 it's success, any other number it's, we failed. We are trying to recreate program true, which successfully does nothing. So it basically will be an empty main with return 0 here at the end, like that. So we can write that, and then save our program. It's now time to compile that simple thing. How can we compile it? So please, if you have taken the computer architecture or the safety management course, so please remind me, how can I compile this program through C into an executable under the same name? True. What should I write here? What program should I use now in that case to turn that high-level code into, of course, some machine code that we can run on the CPU? What do we need to use? You can type it in the chat. Okay, wake up, people. So now that we have our source file, right? Yeah, we can use GCC. And by the way, also a very nice suggestion, right? So we need to specify the output flag, right? Because otherwise, right? You see, if I will just type true C and nothing else, right? So we will get a file called a out. Due to some historic reasons, that's the default name that the GCC compiler will use. You see, so you can actually rename it manually. You can go to your terminal, to your command prompt, and you can use this program MV can rename a file from one name to some other name. It can also move one file to some other directory, or a directory also to some other location. So it can move and rename files. See, like that. So of course I can rename it. I can write so a out, now let's rename to true, right? And we will get our program. So, but probably I would like to get it right away without basically using two commands, right? To get what I want. So how can we do that? Well, we can follow the recommendation here from Dylan, right? So we can use additional flag for our compiler. So, and we'll get the program under an appropriate name. So by the way, in order to check that it's actually true, well, first of all, I will try to delete this old file. Right? And how can I delete a file? Well, for that, also here on most Unix systems, we have a program called rm. Be very careful with this program, because here we don't have a concept of a trash bin, you see? So it means if you delete something, well, you delete it. And usually it's very, very hard to restore that file. Sometimes even, well, impossible. So it depends actually on the file system and, well, what have you done after deleting the file. But nevertheless, so if you will specify the file name or multiple file names, so RM will try to delete those files. So if you will specify the directory name, it will complain that it's a directory and it will not do anything with it. If you want to remove a directory, you need also to write this flag recursive, telling RM to remove not only the directory itself, but all its content inside. So, and if you don't want to answer any confirmations, you can also write this force flag, F flag. But with that flag, you should be very, very careful, because it's very easy to make a mistake, mistype some file name or directory name, and remove files that you actually need. It's very hard after that to restore these files, nearly impossible. See, so, well, it should be very careful with this command. So, but in my case, there's just two files. It's very easy to recreate them if I will make a mistake. So I will just type carefully rm remove, right? And then true, the name of the binary file that I would like to remove. And well, it will of course disappear from this folder. Now we will try to follow the recommendation from Dylan. We will use GCC. We will write O output, and we will write we would like to get a file under the name true. By the way, on Unix usually executables will not have an extension. So on Windows, usually we have an extension .exe and also some others. So, but on Unix, usually, well, binaries, executable programs basically on the disk will not have any extension. You can actually add them. The system here doesn't care. It will run that code anyway. So, but well, it's a common traditional convention here to name executable programs without any extensions. So after that, of course, you write true C, what you would like to use as a source file. Press enter, and in that case you will get your true program. See, like that. So by the way, there is an interesting trick that I recommend you to know about. So probably we haven't discussed it during the computer architecture course or maybe during the safety management course. There is another way how you can quickly get this true file. If you have just one file, not multiple files, just one file, you have a very simple C program, and you would like to quickly convert it to an executable under the same name. So there is a trick how you can do it, well, by just typing one command. Well, how can you do that? I will clear my screen with Ctrl-L key combination, Ctrl-L to clear the screen. And I will write here, instead of GCC, the name of the compiler that we have installed on this system. I will type make. So make is a build system, and we have discussed a little bit on some previous courses, right? So, and make usually requires a make file, a configuration file, where you describe actually how to combine multiple files together for C and C++, and actually any types of programs. You see, so, but well, make has a very interesting thing. So if you will write the name of the file that you would like to get through, so make, if it will not find a make file here, it will try to search for a file called true.c, and it will automatically will try to call the system's default compiler to get the file under the same name. You see, so you don't need to create a make file. If your program consists only of one file, so just write the name of the executable that you want. And if you have a file, a source file with the same name, you see, it will generate an appropriate file. So make here tells me that true is up to date. So in order to test the theory, right, I need to remove the old file. And let me now, once again, by pressing up or Ctrl P on the keyboard, try to run make true again. And you see, indeed, this time you see it will actually call the system's compiler, read the source file, and then output the program under the name true. You see, I will get my true file too. So by the way, why is it not a GCC here? Why is it some CC compiler? Well, CC is usually just a link on the disk. It points to some default compiler, C compiler here installed on the system. Usually it's GCC. So in our case, most likely it was GCC. You see? So, and well, make just uses the default compiler here on the system. Right. So by the way, we also have another compiler here installed called clang or clang, something like that. So, and well, it's also theoretically possible to use it. But well, the default one here is GCC from the GNU organization, a very popular open source C compiler. Okay, so now we know that for small programs, apparently, if we don't care too much about flags, we can write make in the name of the program, right? So it's probably very convenient without typing all these dashes and O and, well, the name itself once again. So we can now use these commands to get our executables. So now that we have this executable, it's time to test whether this executable will actually do its job. First of all, let me actually run once again the system's executable. And how can I do that? How can I do that? Well, I can probably just write true. And how can I be sure that this thing will be the system one and not the one here currently on the disk? Well, if you would like to be sure, you can put as the following here in front. You see, which will try to tell you, this special command program will try to tell you, if you will specify on the command prompt this name, what actual executable from the disk will be, well, executed here, right? So, and if you would like to be sure what is being run here, well, you can use this command. Also could be quite useful. So you can press enter, and you will see that apparently, well, the program, if you will type true, that will run will be started from the directory user bin and true. Well, that's the program. So if we would like to 100% to be sure, we can go and also write user bin true, and we'll start that program. So that is the system one from the system. Now, how can I check that the exit code was actually successful? How can I get this information in this parent process? You see, the bash here is the parent process for the true program, right? The child process that we were trying to start from this environment. So, and these two programs can communicate with one another through different channels. And one of such channels is this exit status code. This exit status code is returned back to the operating system, and the operating system then sends it back to the parent process that was trying to start this child process here. So, and of course, bash also got this information from that process, from the operating system or through it, and we can actually display it here. In what way? Well, there is a special command and also a program on the disk called echo. Its purpose is to just print whatever you will specify on the command line. If you will type here 1, 2, 3, echo will just print that information. How can echo be useful? Well, you see, because bash is also a programming environment, there is a concept of variables. There is a concept of variables. So it's possible here to create variables and then also display them here. You see, if you will do have a variable here, if you will put a $sign here in front of the name of such variable, so here bash before executing some command will replace all these variables with actual content, and then only that sent to that program echo. And that echo can, well, basically display the content of that variable through that trick. Even though, well, nothing special should be written there in echo. Well, there are variables that we can create, and there are some automatic variables. Automatic variables. What does it mean, an automatic variable? So bash creates a number of variables automatically for us, and it also updates them depending on the current state of execution. You see, and one very famous automatic variable is, well, this question mark variable. You see, so it's populated with the last exit status, And if I will run once again true, and now we'll type once again echo and the name of this variable, I will see the exit status of the previous child process that we have started. Well, as you can see, it's indeed 0. So the real system program true, after running, did nothing, you see, and also returned to the operating system that exit code 0. So that exit code 0 was also passed through the kernel to the parent process. So, well, here it can be read and used for some particular reasons. You see, and well, here we do see the 0 here. Here it is. That's how we can get this information. Okay, wonderful. So now let's try to do the same, but with our program. Right, and how can we run our program? Well, hopefully you remember the previous class. So now I don't want to run the system program true. If I will just type true, it will be the program from that location. How can I run my program that I have currently here sitting on the disk? What can I type? Please remind me, right? We have discussed it on the previous class. Yeah, correct. So we can type dot slash and the name of our program. As you can see, also our program did nothing. So, but now we will type echo. We will try to find what is the last exit code. Well, it's also 0. So our program is basically like that true program installed together with this distribution of GNU Linux. Our program does the same. So we were able to recreate it. Was it easy? No, it was rather easy. Right, so here, just a simple entry point with return 0. Apparently here on this operating system, even a program like that has a particular purpose. And now, of course, it's probably time to discuss what is the purpose of such program. Well, okay, we managed to create this program. Okay, but what is this purpose? Right, it does nothing, it just returns this number. So how can we use this number? So remember, I told you that bash is actually a full-fledged programming environment. Right, so we have variables here, we have structured programming elements like loops, selection constructs. So we have for loop, while loop, until even loop, some special loops. So we have for each, we have if constructs, we have switch case, though it's a little bit weird here. So we have a lot of structured programming elements here. We can even technically create here procedures. You see some subroutines that we can run, call functions basically. So, and well, you see what is considered true and false in those constructs. Well, let's try to figure that out. So in order to understand that, I will try to open once again documentation with the main program for my command interpreter, bash. You see, and for that I will write man and bash. It will open a giant file. So bash is a very complex program, and we have a lot of documentation here about it. So in here, hopefully I will see that, well, there are some constructs, structured programming constructs that I'm interested in. What I would like to create here actually in my shell is an infinite loop that will print some message on the screen. And I would like to know what is the syntax to do that. Well, after opening the documentation, well, it's a lot of stuff that I need to scroll through, and I don't want to do that. And by the way, you see, by pressing up and down, that's definitely possible here to scroll through. So remember that the program less here working, right? And the purpose of the program is to display basically all this text page by page. So aside from displaying page by page, I remember that it's possible to search for some text inside of this pager. If I don't want to scroll for 10 minutes here searching for an appropriate piece of documentation, I can just do the following. I can type slash on my keyboard. You see this character. So I will see this prompt here now to enter the search keywords, and I will type what I'm searching for. I'm trying to create an infinite loop, and I will probably use a while construct for that. And I would like to know, do we have actually a while construct here, and how does it look? What is the syntax, his syntax in this programming environment of my command interpreter? After pressing enter, so it will find probably some, you see, words like while. But well, you know what, the first result is not what I want. Right? It's definitely not about the while construct, it's just the word while here in a sentence. How can I jump to the next search result? Well, I remember from my slides, it was the key N on the keyboard. Right? It was the key N on the keyboard. Where do we have man here? Let's search for it. Yeah, less and here, you see N. We can type N on the keyboard and go to the next search result or to the previous one by pressing uppercase N. So I'll press N. Okay, now I will go to some other construct. So, but well, you know what? Well, even though it's a little bit closer in meaning, but still it's something about, well, that I don't need. Let's press N once again. Here we go. Well, now this thing does look like, well, a description of some syntax, right? So for the while construct. Well, you see, apparently, if I would like to create a while loop, I need to write while, then go some list, and at the end should be this semicolon, then do, then list 2 of commands that I would like to repeat, then semicolon again, and then done. Done. That looks very similar to, well, our high-level programming languages. Right, it's probably the major difference here is instead of curly braces, we are using do and done. Do and done. And it's also now just a job of figuring out what is this list 1 and list 2. Well, list 1 is and list 2 is just a bunch of commands. Any command that you can type in bash. It could be internal commands of bash itself. Or it could be a program that you are trying to start. So you see? So, and well, we do know that in many programming languages here eventually something should be evaluated to true or false. So that the loop will continue or not, or stop, right? So, and well, if we can run here programs, well, how can we figure out which program was returning true and what program was returning false? How can we actually figure that out? Well, once again, it's the status code. Status code. You see, so this exit status. So you can run actually here any programs you want. You see, so and they can do something, maybe check something. So by returning the 0 or any other number, here it will be interpreted as true and false. And what will be true? What will be true? So well, it's written here, right? So true will be 0. Will be 0. So and false will be any non-zero exit status code. You see? So as long as there is 0, so this thing will be repeated in list 2. So, but well, if we will get there a non-zero exit status, it means failure. It means false. So in that case, well, this loop will stop. You see, so here 0 is actually considered as true, and any other number is false. By the way, people from computer architecture and safety management, can you remind me, what was actually true and false in C? In bash, in this command prompt environment, apparently 0 is true and anything else is false. But what is true and false in C, in the C programming language? Also C++ too, to that extent. If we recall those languages, numbers are also, well, considered as Boolean values in C and C++. And what numbers are considered true, to be true, or trucy, and what numbers are considered falsy in the C and C++ programming languages. Well, in the C programming language, 0 was false. I agree with that. 0 was false. In the C programming language, 0 was false. You see here, it's a complete opposite thing in bash. Please don't get confused. In C and C++, 0 is false. Here in bash, 0 is true. Complete opposite. You see? Because 0 exit status code is success, right? For the program. So here it's interpreted as true. But in the C language itself, if you will try to write some if construct or while loop, in that language, 0 will be false, an opposite thing. So don't get confused. It's very often that we write C programs, then we write some scripts, and sometimes, well, it turns into a complete mess in our head. What is what? So don't get confused. Because an exit status of 0 means success, here it's interpreted as true. So, but in the C programming language itself, if you will try to write any structured programming element like while loop, for loop, or anything else, right? So 0 will be considered false. And what is true in the C programming language? What is true? For now, we don't have actually kind of like completely correct answer. So Dylan is very close. Well, yes, 1 is considered true in C. But what else is also considered true? Well, actually, any other number except for 0 is considered true in the C programming language. Zero is false in C programming language. Any other number, 1, -1, -42, all of them are considered true in the C programming language. You see, here it's an opposite. 0 is true and any other number is false. Don't get confused. So now that we know, apparently here you see we can run this construct and, well, what could be our Boolean value? Well, apparently it could be result, an exit status of any program that we can run here. Right, so well, let's try to create an infinite loop following this syntax. So I will exit from this manual pager less by pressing Q on the keyboard. I will now try to create this infinite loop. So I will write while, and for first of all, I will try to use the true from the system, the true program from the system, not mine, but from the system true. Now I will write this semicolon here. I will write do. Then whatever I would like to do, well, I will just print hello world. Like that. So, and then it was written, I need to write done. Some people sometimes ask, is there a reason you have a white space here after the command? Well, modern shells like Bash can actually interpret this semicolon correctly without any major problems. But some older actually shells can get confused. Semicolon, is it part of the name of the program, or is it actually part of this shell syntax? You see, so it was very common to put this white space to kind of keep some backward compatibility. So now after writing all that stuff, as you can see, instead of curly braces, we have here do and done. I can press enter. Well, what do you know, right? It's an infinite loop. And now we print hello world again and again. Well, consuming basically time on our CPU. So, if you would like to stop this process, you can send a special signal to this program. So with the Ctrl-C key combination. Ctrl-C, like copy. So by the way, on Windows, if the program will not stop, you should just wait a little bit. Press Ctrl-C and wait a little bit. You can even press multiple times. So and then wait a little bit. Not always will it stop right away. So sometimes you need to wait a little bit, especially if you are in Git Bash. So here on macOS, usually it's a bit more responsive. Just pressing Ctrl-C once, usually it will stop right away. So, but Ctrl-C will sends a special signal to that program, Bash, and well, usually, well, it interprets it to stop whatever it's currently trying to do. So signal is another interprocess communication mechanism that eventually we will discuss. So, but well, here usually this special signal to tell programs to stop whatever they are doing. Well, it's mapped to the Ctrl-C combination. And that's by the way, Ctrl-C and Ctrl-V doesn't work as you expect inside of such environment. You see? So now that we have stopped this program, we've realized, oh, well, you know what? Well, apparently, yes, this true program could be useful. You see? So it can help us to create here an infinite loop, right? So it can also be used to check whether something is true or false. There are some, for example, programs which allow you to check one exit code with another exit code. See, and here you can even write these combined commands. There are even logical operators and many other things that you can utilize here. You see, but it works in a very strange way, but starting other programs. It's not actually true for modern shells. Modern shells actually usually will run these common things directly inside of their environment to speed up the execution. But in a classical Bourne shell, it was actually how it was working. You see, this construct was starting other programs, getting through the operating system the exit status code, and then interpreting 0 as success, no any other number, as failure, as true and false, and then doing something here or stopping the execution of the script. See, like that. Here how it works. So now let's try our oven true. So for that here I will write not while, write true from the system, but dot and slash and true. Will the infinite loop still work? Yeah, you see it still works here without any problems. Okay, by pressing Ctrl C we can of course stop this process. Once again, on Git Bash you sometimes have to wait a little bit or press Ctrl C multiple times. Is this environment weird? Yes, it's a little bit weird. Unix shells are a little bit weird. Right, so how they basically combine some elements of the programming syntax, which is interpreted here in the common interpreter itself, right, internally, and how certain things are delegated to other programs on the system, right? For example, for some Boolean expression, well, some program is being started and its exit code is being analyzed, right? To do something else useful, other programs are being run and also do something useful. So, well, it's a little bit weird, but you know what? It's incredibly powerful due to that reason. Because you now see, it means what? Well, if you need some complex check here in your while loop, you can actually write whatever program you want, in whatever language you want. You see, and it's just about this exit code at the end. Right, so if you will return from your program in any language exit code 0, it will be considered true, and well, it could be kind of like a signal here to continue doing work inside of a script. So, but if your complex script somewhere, right, so we'll do something else and return non-zero exit status code. So in that case, well, some loop in the script will stop. And you see, basically, you can have a lot of power starting different programs in different languages installed on your system here, right? So to run them one after another, to run one program, so other programs depending on the condition, right? To run them once on multiple times. So, and if you need very complicated checks, you can just write a program and use whatever libraries, whatever construct you have there, whatever facilities. Just don't forget about returning 0 or some other code here at the end. You see, this simple number, this small number, which is returned from the program, could be utilized here to create this wonderful scripting environment, which helps a lot of developers and administrators to automate their daily work and to extend this environment just by writing programs in whatever language they want. So you see, making the whole system incredibly diverse, right? Powerful, configurable, extensible, right? Just install or write another program. And this zero code will somehow allow you in these scripts to organize, to automate some work on the computer. Thing like that. So by the way, if you will go back to man bash and you will search for this while, you will also see there is an if construct. So instead of curly braces, we have here then, and instead of else if, we have elif. You see, the syntax is a little bit different. But other than that, it's also a full-fledged if construct. See? So also we have switch case, though it works a little bit differently. So it's considerably more powerful here in this environment. So we also have some other things here. See some loops, the classical one, right? So from what to what, with what step to repeat something, right? And even for each, which is quite useful here in this environment. There are even, of course, a possibility to use logical operators, so negation, you can group expressions and stuff like that. And you see a wonderful thing that internally, all these expressions, they could contain commands or other programs that we will start. And those programs could be written in any language you want. Well, you see, the environment is indeed a little bit weird, but overall, I think the ideas presented here are incredibly powerful. So, and Unix is full of such interesting ideas. You see a lot of interesting ideas like that. are all over the place. And that's probably one of the reasons Unix became so popular, was cloned so many times, and so many basically look-alike systems were created with similar ideas, similar abstractions, similar interprocess communication mechanisms. Okay, so now to prove that we can write a program in any other language, we will try actually to write a program in some other language. So let's try to write exactly the same program, but now in a language called Rust. So I will do it here by opening my editor, and you can open any one you want. But this time, instead of writing true.c, I will write true.rs. And before writing this program, we should probably discuss a little bit on what is Rust and why are we going to study it here on this course. By the way, I think study it's not the correct word here. We're not going to study here. This course is not to study Rust. This course is to present you some fundamental ideas of the operating system, theoretical and practical, for high-level application developers. And the most important thing, I think, it's of course how can we communicate with the operating system and other programs through various different mechanisms. And one of them is a simple, basically, exit status code. So, but still, well, probably to get some other important skills, well, could be useful on this course. So, and maybe make this course a bit more interesting. So, in this year, as an experiment, we are trying to also to write some programs in Rust here. But please remember that while learning this language itself, if you are interested in it, it will be your job. We will just in general discuss what is Rust, so what kind of interesting ideas, unique ideas are there in the language, and we will help you to write some common Unix utilities in this language. If you are interested to fully study this language, you should probably jump here to this learn basically page on the official website. There will be a number of recommendations of some books, some official books, some unofficial books. There are also an interesting environment where you can try out Rust. So, and also get all the other information. So, but well, for now, let's just discuss the following. What is the purpose of this language? We know a lot of languages just doesn't appear, well, just because. Right? There is usually some reason. Well, first of all, let's recall what was the reason for Java. Right? It was the language that we were studying during the first year. What was the differentiators of Java? Right? What was unique about Java? Well, who can tell me? The key differentiators of Java. How was it different from languages before it? Specifically C and C++. Right? How Java was different? Well, we have very good answers here. First of all, safety, right? So compared to C and C++, Java was bringing safety to the table. Right, very good. Another good answer from Big John. Object-oriented programming from the very beginning. Right, even the basic Hello World program, well, should have a class. Right, so object-oriented programming directly kind of like as fundamental part of the language. Right, so another thing is probably also cross-platformability, something like that. Right, an ability to generate one byte code file and then distribute it to all your clients on different systems. And those clients, if they do have Java virtual machine installed, they can run your one file, right, the same file, on all their CPUs, operating systems, well, exactly the same file, if they have a virtual machine installed. So it was kind of like the idea of write once, run anywhere. Whether it was actually, well, they managed to achieve it or not, it's a whole different topic of discussion. Yeah, but it's also something they wanted to put on the table. Safety, good abstractions, object-oriented kind of like by default from the fundamental structural elements, and also, well, cross-platformability. Right, that's Java. So now let's discuss Rust from exactly the same point of view. We have so many other languages, right? Why the Rust language was created? Well, first of all, the initial development was started and funded and sponsored by the organization called Mozilla. And well, can you tell me what is Mozilla as a company is famous for? Which product? Which program? Maybe some of you even use it on a daily basis. Mozilla. What are they famous for? So the Firefox browser, correct, correct. So they are famous for the Firefox browser, right? So and well, you see, with browsers, it's a very interesting thing. Most browsers nowadays are written in C. Most browsers are written, I'm sorry, not in C, in C++, in C++. Most browsers nowadays are written in C++. At least the core part of the browser. Its rendering engines and some other key components. So Firefox is written in C++. Chrome and Chromium, the Chromium project is written in C++, and all the browser from Chromium, Microsoft Edge, Opera, and so many others, they're also basically C++ programs, mostly. Safari with WebKit, also a C++ program. Even though Apple invests a lot into Swift, Objective-C, and the UI maybe in some way maybe written in Swift or Objective-C or something like that. But well, it's still, at the core, it's a C++ program. So, and why C++ is used for browsers? Well, because probably, well, first of all, these programs must be very performant. So it means we need a language which is close to the hardware, right? It's a language which is compiled directly to the machine code. And also, well, we need good abstractions, right? Because these are very complicated programs. We need some good abstractions in the language. Like, for example, elements of object-oriented programming. And well, in C++, we do have those elements, right? So, well, first of all, C++ is fast. And also, now we have pretty decent abstractions there, object-oriented, functional in the language itself. So C++ for many years was a language of choice for many such systems, such as browsers. So, but we see there is a major problem with C++. And what is that problem? Who can tell me? So yeah, C++ is great from the point of performance and abstractions. But well, there is one minor problem with, maybe not a minor, major problem with C++. And what is it? Is it easy to write memory safe code in C++? Well, if you are limiting yourself maybe to only just C++ constructs, maybe it is. So, but you see, due to a number of reasons, especially in such complex projects, well, people use unsafe C code in C++. So, and well, also, well, memory is not automatically managed in C++ by default. And due to that reason, developers make a lot of mistakes, leak memory, do all kinds of make other mistakes with memory. So there are a lot of problems with pointers, dangling pointers, and so many other things like that from the point of safety, from the point of memory efficiency in C++ programs. It's a very common problem, and through it, a lot of attacks are performed on various browsers nowadays. So some developers from Firefox, they decided, well, we don't have anything better. So maybe if we don't have anything better, maybe we can just create it. And we got the Rust programming language. So you see the idea that is Rust compiled to machine code. So the programs are very fast. The runtime system is very small, so that it's easy to port it to various systems on different CPUs and on different operating systems. So the runtime system is very small. Compared to C++, it's even smaller. It's closer to the runtime system of C. And also the language which is safe. Safe. By default. You see, and from many points of view. Especially from the point of memory usage. So some common problems that exist even still up to these days in C++, Rust compiler during the compilation time, basically offline, is trying to solve, trying to prove that your code is correct or not. Maybe there is a possibility of misusing memory in one way or form. So you see, safety is here more important, maybe even more important than in Java. So certain things that we have in Java, well, here they are prohibited in Rust unless you turn those features off. So, and well, they've developed a language like that. Well, they failed, of course, to rewrite the whole thing into this language. The Firefox browser is still mostly written in C++, but they are planning maybe component by component, improving the security of some subsystems by rewriting now them in Rust. By the way, even though Rust is a considerably young language, it has already managed to find its own niche, you see, specifically in the system development field. So in the field of developing kernels of the operating system, in the field of developing drivers of existing operating systems, in the field of developing these system utility programs, a lot of stuff is now being written or rewritten in Rust. So, and specifically some good news, so that for the first time, I think in many years, in the very hopefully near future, drivers written in Rust will be accepted into the Linux kernel. For many years, it was only possible to use C in order to write drivers for the GNU Linux, basically operating system, and well, for the Linux kernel in general. So, but now even Torvalds apparently blessed the idea that we will give the Rust runtime a place in the Linux kernel itself, and we will allow some subsystems, specifically drivers, to be written in this programming language. We believe there is, well, a reason for that, because, well, it will probably make some of those drivers much safer. Well, apparently even Linus, which is a big proponent of C, decided that, well, it's fine. Also, Android developers from Google, they also decided to allow to write drivers in Rust. So, and well, they are even planning some high-level Java virtual machine additions to simplify the communication between different levels. So, Rust is becoming popular in the system programming field, and well, why not to try to use it on this system basically development course. Now, in the last 5 or 2 minutes that we have, let's very quickly write a very similar program. So first of all, how is the entry point looks in Rust? Well, it looks something like the following. You write fn, and then you write main, like it was in C. So no surprises here. Okay, where is I? Here we go. After that, you put your curly braces. Here, usually people prefer to put it like in Java on the same line, and then of course goes the body of this function. Like that. So no surprises. So, but even though theoretically speaking, it's possible to return certain things from main, but well, it can't be a number. And for now, you can just pretend that this is a void function. It returns nothing. So, well, here now is the question. So, in that case, if it returns nothing, how can we return the exit status? So, well, in order to answer that question, let's actually answer the following question. So, do you remember how in Java was it possible to return an exit code? Let's recall structured programming and object-oriented programming. And tell me, please, how was it possible in Java to return an exit status code? If you recall, the entry point in Java is public static void main. So it was also a method that was returning nothing. Then how was it possible in Java to tell that we are successful or not? Who remembers? If we will be able to answer that question, probably we'll be able to answer how to do it here in this language. And we got the answer in the chat. So Dylan writes here, system exit. That's a correct answer, right? So there was a class system, and inside of this class, there was a static method exit, and this exit was able to stop the program and also return to the operating system the same status code. Right? And you can decide whether it's 0 or something else, right? So, well, a very similar idea is here in Rust. You see, because, well, we've decided here not to return anything. And by the way, it's possible to return, but, well, it's not what you expect. Is it possible to return here? That's why for now we'll just pretend we return nothing. So, well, we just need to find an appropriate function here, like it was, for example, in Java. So, and for that, I will go to the official documentation. I'll just write exit. Maybe there is a command like that. And what do you know? You see in the official documentation, there exists actually a function that will terminate the current process with a specified exit code. You see, so this function accepts an i32. It's an integer 32-bit data type here in Rust. You see it's written like that. Very nice. i32, very clean. And this function never returns. When we have this exclamation mark, it means here this function never returns. It's not that it returns nothing. It never returns. We never exit from this function. And it does make sense, right? Because, well, after it, the process stops. So, and well, how to use it? Well, you need to bring this namespace here. You can directly specify this namespace and call exit. Or like in C++, you can write use std standard library. Then the namespace for the process, right? Process. And well, there we have a function exit. Then after bringing it here, you can call exit and with whatever exit code you want. Well, in my case, of course, I can write exit 0. So by the way, at the end, a semicolon here is very important. Even though a lot of modern languages like Swift and Go, they decided to allow you not to write a semicolon if you don't want. So here the semicolon is still strictly necessary. If you don't have a semicolon at the end of your function, in Rust, well, this thing has a special meaning, and that's not what we want here. So here semicolon for this particular statement is absolutely necessary. So by the way, if you don't want to bring that thing here, in that way you can also, instead of using writing use, right, you can just directly specify this thing here. Process exit. Somewhat similar to C++, right? So now after saving that stuff and exiting, how can we compile that? Well, first of all, you need to actually install Rust. And how can you do that? Well, Rust is installed here by default, not system-wide, but for any particular student. So you need to go to this page. Let me copy the link. You need to go to this page. And then you need to execute this line. And then you need to execute this line. It will ask you, would you like to continue? You need to press 1 to continue, and then eventually Rust will be installed into your home directory. So it's installed per user, you see. After that, you have to disconnect from your server, reconnect again, and after that you will be able to use Rust. In my case, of course, Rust is available for my user, so I will just write rustc. It's the name of the compiler for Rust, and then the name of the program, trueRS. Here you don't need to write the output flag. It will automatically generate a program here under the same name true. So if you still believe it's the old C program, so we can remove it and we can run the compiler again. It will not complain. You will get your program true and you can try and use it. True. Here we go, it's 0. And can we use it in this infinite loop? So by the way, you see, instead of going through the history, it was also possible for me to press Ctrl R, write while. I remember there was a command like that, right? And then, well, of course, find my previous command while. As you can see, it still works. See, it still works. So with this while, I can still use now a program written in a different programming language, but because it uses exactly the same channel of communication with the operating system and with the parent process, well, this bash scripting still continues working. You see, it's still possible in this program to get that exit status code from that child process and use it here in this while loop construct. So, well, here we go. Now your homework will be to try to do the same and to create a program called false. So, well, probably you realize at this point that it will be very easy. Also do it in C and in Rust. So it will be very easy. I also recommend you to probably reuse some existing code with the command copy. The copy command allows you to create duplicates of your files. So you can probably create a copy of true from C and Rust and rename the new file and put the name of the new file false C and RS. And then, of course, by changing some numbers there, well, you can create your false programs. It's just a matter of figuring out what is returned by false. Well, try to do it on your own. So, and create the false program. You see, surprisingly, even such simple programs like that, well, are fundamental things that are installed together with the operating system. Well, for us, it was very easy to recreate them. Next time, we will try to create more complicated programs, specifically the program called Echo that we were using heavily today. So, and we will try to see how that program is actually functioning and working here. And we will once again try to do it in multiple environments, Rust and also C. That is it for today, so thank you for your attention. No specific tasks for the next week. So don't worry, false, you don't need to submit anywhere, and just try to prepare it for the discussion during the next practice class. So, but we are coming closer and closer to the topic of system calls and also the first project. So be ready for the next lecture class. Maybe we'll start discussion there. That's it. Thank you very much. Sorry for taking some of your breaks time. Goodbye. Until the next time.